Okay, LeetCode problem 2130, maximum twin sum of a linked list. So in a linked list of size n, where n is even, the ith node, zero indexed. Okay, all this means is you've got a singly linked list that has index values like normal. Don't be confused by LeetCode's awkward wording. So the twin sum is defined as the sum of a node and its twin is basically the opposite. So you've got the even list. So 5, its twin is 1, 4 is 2. So basically just the opposite. So like the first and last, the second to first and second to last, those would be the pairs, and then the max sum of those. So 5 and 1, obviously 5 and 1 is 6, and 4 and 2 is 6. Okay, so they both have the same high value. And here 4 and 3, 7, obviously that's more than 4, so the highest twin pair sum is going to be 7. So we will do this problem by, you could allocate it into an array, which would be O of n. But if you use a slow and fast pointer, you can reduce this down to constant time. So we'll do slow. So I'll set a slow pointer and let fat head, and let it breathe. No. Okay, so if you're unfamiliar with slow and fast pointers, you increase slow to its next every iteration and fast to next. So think about an array. If you start 2 pointers from the beginning of the array at index 0, and you go one of those pointers from 0 to 1, and then one of those pointers from 0 to 2, and you keep doing that, so it would be 0 to 2 and then 0 to 4. The fast one is always going to be twice as ahead as the slow one. So when your fast gets to the end, you know your slow pointer is going to be exactly in the middle. And to solve this problem, we're going to reverse the first half of the list, because if you reverse the first half of the list, all of the twin pairs are now an equal distance away from each other. So you can calculate each of their sums and update your answer as you go. So I started at a slow and fast pointer. So I'll do while fast and fast dot next, because you want to be able to have, you want enough wiggle room to be able to complete your code or complete the algorithm. So while fast and fast dot next. Let's see. What's it doing? I'm going to fast equals fast dot next. So you're setting fast again 2 spots ahead, so 0, 1, 2. So fast would be a 2, and then we're going to set a temp variable to slow dot next, and then slow dot next to your prev value. The slow here. So if you separate this code, just this context here is very similar to the reversal algorithm. Instead of cur, we use slow. So you've got your fast here, your temp here, and your slow is pointing to the previous value, which has not been assigned yet. So then I'll do slow dot next equals prev, and then prev equals slow, and then slow equals temp, because you needed something after that initial variable to hold your temp value so you wouldn't lose it. So now slow, so you've got fast, slow, temporary, and previous, and that slow pointer was now pointed to the temporary. So it's hard to visualize. So you just kind of need to know the algorithm and be able to picture each step in your mind. That's how I've learned it. Okay, so that looks correct. So we've reversed the first half of the list because we've stopped when slow was at the middle, and there were no more fast dot next left. So we know we are in the middle of the list. So I'm going to create an answer variable, and then while we have a slow pointer to a node, so while a slow pointer exists, we're going to update our answer with the max of our current answer or the previous value plus, you probably can't see, plus the slow value, and then increment both of those to their next values. So you know you have the right answer. So you return the answer, run it, and this should work. It looks like it works.